Today we're going to look at the derivatives of trigonometric functions, exponential functions, and logarithmic functions. So far we've only looked at derivatives of polynomial functions and rational functions. So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. The derivative of cosecant is negative cosecant cotangent. The derivative of secant is secant tangent, and the derivative of cotangent is negative cosecant squared. So the first one we're going to look at is f of theta equals 2 square root of theta plus 3 cosine theta. We're trying to figure out what is the derivative of that function. So, first we have to rewrite the square root as a power. So that would be theta raised to the 1/2 power plus 3 cosine. And so then if we apply the power rule, that'd be 1/2 times 2, which is 1. So then 1/2 minus 1 is negative 1/2. Plus 3 times the derivative of cosine. The derivative of cosine is sine. And so then all you have to do is make that a positive exponent for your final answer. So that means we have 1 over theta to the 1/2 power plus 3 sine theta. And if it asks for no rational exponents, then you would change that to a square root. So 1 over the square root of theta plus 3 sine theta. Okay? So that's our first example on the derivative, applying the derivative of trigonometric functions. For our second one, we're going to write the equation of the tangent line. So if you remember, the equation of the tangent line is y minus y1 equals m times x minus x1. And in order for us to find our slope, we have to find the derivative and then plug the x value in. And then we're actually already given the coordinate point. So all we need to do right now is find the derivative of negative 2 tangent. So the derivative of negative 2 tangent would be dy over dx equals negative 2. The derivative of tangent is secant squared. And so then, since we want to know what the equation of the tangent line is, if we plug in our given x value, which is negative pi, and then we could find the coterminal angle so that we can actually evaluate it on the unit circle. So if we add 2 pi, we get positive pi. Okay. So then if we look at our unit circle, pi is negative 1 comma 0. The reciprocal of secant is cosine, which is your x value. So in this case, that would just be negative 2 times negative 1 squared, which is negative 2 times 1, which of course is negative 2. So that means that's our slope. So then that means the equation of the tangent line is y minus 0 equals negative 2 x plus pi. Okay. So our next problem says f of x equals 2x times cosine of x. And we want to know what is the slope of the tangent line to the graph. So the first thing we need to do is find the derivative. Well, here we have two things that are being multiplied, so we need to apply the product rule. If you remember, the product rule is f prime of g plus f times g prime. So if we do that, that means we're taking the derivative of f, which is the, in this case, that would be the 2x. So the derivative of our first piece would be 2 times cosine of x plus 2x times the derivative of cosine. The derivative of cosine is negative sine. Okay, so then that would just be 2 cosine of x minus 2x sine of x. Then it wants to know what's the slope of the tangent line, so that means that we need to plug in our pi over 2. Okay, so if we look at our unit circle, pi over 2, the coordinate point is 0, 1. So cosine is your x value, so we'd have 2 times 0 minus 2 pi divided by pi, that'd be pi, times sine of pi over 2 is the y value, so that's times 1. So that means in this case, the entire thing, the slope is negative pi. And in this case, it just wanted the slope of the tangent line, so that's all we have to find. We don't have to find the equation of the tangent line. Okay. So this is applying derivative of trigonometric functions with the product rule. So then let's look at applying the derivative of a trigonometric function with the quotient rule. Here we have two things that are dividing, cotangent of x divided by 1 minus sine of x. So first of all, remember that the derivative for a quotient rule is f prime of g minus f g prime all over g squared. Okay. So that means this one would be dy over dx equals the derivative of cotangent, which is negative cosecant squared, times g. Our g is the bottom, minus f, which is cotangent, times the derivative of the denominator, 1 minus sine x. Well, the derivative of sine is cosine, so that would just be negative cosine, since there's a negative on the outside of the sine. And then divided by g squared. Our g is 1 minus sine of x squared. Okay. So then if we look at the derivative of exponential and logarithmic functions, the derivative of e to the x is actually just e to the x. The derivative of a number raised to the x is that number raised to the x times the logarithm of that number. So like, for example, if you have 7, for example, if you had 7 raised to the x, that means that the derivative would be 7 raised to the x times ln of 7. That's what that means, okay? All right, so then the derivative of natural log of x is just 1 divided by x. All right, so let's look at this first example here. This one, we're applying the product rule since we have two things that are being multiplied. So this is our f, and this is our g. So if we are reminded of our formula, we have f prime of g plus f times g prime. So the derivative of the first piece, well, we got to rewrite it as 3x to the negative 5. So the derivative of that would be negative 15 x to the negative 6 plus 2 times g, so 7 raised to x, plus f times the derivative of g. In this case, that would be 7 raised to the x ln of 7. And then because this was y, you'd say dy over dx equals. Okay. All right, and then on our final one, here we are applying the quotient rule, so that's f prime of g minus f times g prime divided by g squared. So that means that would be f prime, which would be 4 cosine minus 10x times g, so times 21 e to the x, minus f times the derivative of g. So that's, remember, the derivative of e to the x is just e to the x, so times 21 e to the x. All divided by g squared, so all divided by 21 e to the x squared. And since this is h of x, we'd say h prime of x. And that's it. So that's how you apply the derivative rule. Now, sometimes they'll have you simplify and sometimes they won't. Like in this case, they're all being multiplied by 21 e to the x. So this might be a case where they have you simplify it, as in if all the pieces are being multiplied by 21x e to the x, then it would reduce like such. Okay? It all just depends on the examples or the directions, but other than that, you applied the quotient rule and the power rule and the product rule with trigonometric, exponential, and logarithmic functions.